This lesson is over quadratic functions. Quadratic equation is of the form ax squared plus bx plus c equals 0. Now let's look at quadratic function. Well, quadratic function must have function notation, which means it is of the form f of x equals ax squared plus bx plus c. Now, for these to be quadratics, you need to remember a, b, and c represent real numbers, and a cannot equal 0. Now, quadratics are not new to us. We are familiar with finding the solutions or roots to quadratic equations, but what about quadratic functions? Well, for quadratic functions, we find what's called the zeros. If the 0 is a real number, then it is the first coordinate of the x-intercept. Now remember, an x-intercept is where the graph crosses the x-axis. It is a point, and the x-intercept will always be where the y value equals 0. Now, if the 0 is an imaginary number, then the function does not have an x-intercept, which simply means the graph does not cross the x-axis. Example 1, identify the zeros and the x-intercepts. For A, we have f of x equals 3x squared plus x minus 2. Now notice the directions. Identify the zeros. That's giving you a clue. It's telling you to set the function equal to 0. So, looking at the function, in place of f of x, we put a value of 0. So now we have 0 equals 3x squared plus x minus 2. Now we're looking at an equation. Is this linear, quadratic? Well, this is quadratic. Now look for more clues. It's a quadratic that has x squared and x. Since it has both x squared and x, we can try factoring, and if that doesn't work, we can try the quadratic formula. But let's try factoring first. So on the side of our paper, we have some side work. We take the expression 3x squared plus x minus 2, and we factor using the AC method. We multiply our leading coefficient times our constant, and we get negative 6. From here, we come up with our list of multiples, and then we look at the sign. Since it is a negative 6, that means it must subtract to equal the middle term, which in this case is a positive 1. So from our list, we see which combination of subtraction could possibly give us 1. And our options are 2 minus 3 or 3 minus 2. For the result to be a positive 1, it must be 3 minus 2, so we expand the middle term. We now see 3x squared plus 3x minus 2x minus 2. Since we have 4 terms, we do factor by grouping. Looking at the first 2 terms, we see they have a 3x in common, leaving us with x plus 1. The last 2 terms have a negative 2 in common, and when we factor that out, it leaves us with x plus 1. Now looking at both terms, we see they both have a value of x plus 1. And so when you factor that out, it leaves you with 3x minus 2. Now we have factored the equation. So we take the factored form back into the equation, which means we now have 0 equals x plus 1 times 3x minus 2. Since this is of the form some number times some number equals 0, well, that means one of the numbers must be 0. So we take each value and set it equal to 0. The first value, x plus 1, we set it equal to 0. We take the second value, 3x minus 2, and set it equal to 0. And now we solve the equations individually. The first equation, we subtract 1 on both sides, and we find x equals negative 1. For the second equation, we add 2 to both sides, and then divide both sides by 3, and we find x equals 2/3. Now it appears we found the solutions, but we're not asked to find the solutions. Instead, we're asked to find the zeros. Since we're talking about functions, we now refer to it as zeros. So our zeros in this case would be x equals -1 and x equals 2/3. Now, are our zeros real or imaginary? Since the zeros are real numbers, then we can identify the x-intercepts. The x-intercepts are points consisting of an x and y value. The first x-intercept would be -1, 0, and the other x-intercept would be 2/3, 0. Example B. We have g of x equals 4x squared minus 12. Now again, we're being asked to find the zeros, which means set the function equal to 0. So in place of g of x, we put a 0, and now we have 0 equals 4x squared minus 12. Now we look. Since this is a quadratic, we look for clues. Does this have x squared and x? Or does this only have x squared? Well, since this one only has x squared, it means we need to isolate the x squared and get it by itself. So to do that, we need to add 12 to both sides, giving us 12 equals 4x squared. From here, we need to undo the multiplication, so we need to divide the right side and the left side by 4, which simplifies to give us x squared equals 3. So now that we've isolated x squared, we're ready to solve for x. But how do you undo squaring something? Well, you use the square root property, which means you can take the square root of one side as long as you take the square root of the other side, but don't forget about the plus or minus. So the square root and the square undo each other, giving you x by itself, and the 3 under the radical cannot be simplified. So we're left with x equals plus or minus square root 3. Since we have plus or minus, that means we have two possibilities, and we need to separate them. The first possibility would be x equals square root 3. The other possibility would be x equals negative square root 3. Now, although we think of these as solutions, we have to remember we're dealing with a function. So for functions, we now call these zeros. Now looking at your zeros, are these real or imaginary? Well, these are real, which means we do need to find our x-intercepts. The first x-intercept would be square root 3, 0. And the second x-intercept would be negative square root 3, 0. For C, we have h of x equals x squared plus 16. Again, since we're being asked to find zeros, we set the function equal to 0, which means we now have 0 equals x squared plus 16. Looking at the equation, we look for clues. Notice we only have x squared, which means we need to isolate it. In order to do that, we need to subtract 16 on both sides. That gives us negative 16 equals x squared. Now, we've isolated x squared, but I need to solve for x, so I need to undo squaring something, which means we need to apply the square root property. So we will take the square root of one side and the other side, but don't forget about the plus or minus. Now the square root and the square undo each other, giving you x equals, but look under the radical. What do you notice? Well, there's a negative. And anytime you have a negative under a square root, what letter just got introduced? Well, that would be the letter I. So we've taken care of the negative under the radical, which means we still have square root 16. Well, we know the square root of 16 is 4, and we can't forget about the plus or minus. Since we have the plus or minus, we have two separate solutions, are two separate answers, which we do need to separate. That means we have x equals positive 4i and x equals negative 4i. And again, what do we call these? These are our zeros. Now look at your zeros. Are they real or imaginary? Well, since in this case the zeros are imaginary because we have the I, then the function does not have any x-intercepts, which means you would simply write the word none. The graph of a quadratic function is a parabola. As a reminder, that's that U-shaped graph. Now recall, f of x equals x squared is a basic function of a quadratic. But what if we change it slightly? If I were to rewrite it as f of x equals a times x squared, recall that a would cause it to have a vertical stretch or shrink. Also, if a were to be negative, it would cause the graph to have a reflection across the x-axis. Now, what if I were to change that equation just slightly? Say I were to write it as f of x equals a parentheses x minus h close parentheses squared. How would that change the graph? Well, since it's inside the function, it will be a horizontal change, which in this case is going to be a horizontal shift left or right. So it's physically going to move the graph left or right. Now what if I take that function and change it slightly? Say I were to write it as f of x equals a parentheses x minus h close parentheses squared plus k. What does the plus k do to the graph? Well, since it's outside the function, it is vertical related, and specifically, it'll be a vertical shift, meaning it's moving the graph either up or down. Now looking at that specific function, it turns out the point hk is where the graph turns or changes directions is called the vertex. Now, the max or min value of the function occurs at this particular point. Maxima or max is the highest point, and since it's the highest point, it is represented by the y value known as k. Now, if you were to have a maximum, that means that the graph must be facing downwards, and it has one particular high point, which we would call the max, which is represented by your k value. Now, what if you had an upward-facing parabola? That would create a minima or a min, which is the lowest point on the graph. Again, since it is the lowest point, it is a minimum, but it's still going to be represented by your k value. Think of it this way. When you think of maximum or minimum, you're either looking up really high or down really low. Which axis goes up and down? Well, that's your y-axis, which means it's always going to pertain to your y value. Now, through the vertex hk, there passes a vertical line of the form x equals h, which is called the axis of symmetry. Now, putting all this together, we want to summarize. If we have the function f of x equals a parentheses x minus h close parentheses squared plus k. Now, we're assuming that if the a value in front of the parentheses set is greater than 0 or positive, it will create an upward facing parabola, like so. Now, on this parabola, as you're reading it from left to right, we see that the graph is going down, down, down. Then we hit the low point, and then it changes directions and then begins to be traveling up, up, up. The point at which it changes directions is referred to as the vertex, or h, k. In this particular case, because that is the lowest point on the graph, we say it has a minimum or min, and since it's the lowest point, we call the min value k. Now, passing through the vertex, we have a vertical line known as the axis of symmetry. Since it is a vertical line, it is represented by the equation x equals. Specifically, it will be x equals h, or whatever your x value happens to be in your vertex. Now that is if your value of a is positive. If your value of a is negative or less than 0, it will be a downward facing parabola. Since it's a downward facing parabola, it has a slightly different characteristic. We read the graph from left to right and we say it's going up, up, up. Then it hits this high point and then it changes directions and begins to be traveling down, down, down. Now at the point where it changes directions, we call that the vertex, which is represented by hk. As we look at the graph, we see it has a high point, which means we refer to that as the max or maxima. The maximum is always represented by the k value of the vertex. Again, we will have a vertical line traveling through the vertex, and a vertical line is always represented of the form x equals. And since it's passing through the vertex, it will be represented by x equals h. So we have two possibilities. The upward facing parabola, which is where a is positive, means it will have a minimum. And then the other possibility is a downward facing parabola, which means the a value is negative, which means it has a maximum. Example 1. Identify the following. For a, we have the function f of x equals 3 parentheses x minus 4 close parentheses squared minus 6. And we're being asked to identify the vertex, axis of symmetry, max or min, and the max or min value. All right, so as a helpful reminder, here is what we're looking at. The form of the function f of x equals a parentheses x minus h close parentheses squared plus k. The first part asks us to identify the vertex. Now remember, the vertex is a point, it's an ordered pair, which means we're looking for our hk value. Well, h is always found inside the function, and if we look inside the function, we see the value 4. So our h value is 4. Now to find our k value, that's the vertical movement, which happens outside the function. So we look outside the function, and we see minus 6. So our k value is minus 6. Next, to find the axis of symmetry. Axis of symmetry is always an equation because it's a vertical line, and it's always of the form x equals h. Well, do we know our h value? Yes. So our axis of symmetry is x equals 4. Now to determine the max or min. Basically, it means, is our parabola facing upwards or downwards? Well, to find out, we look at the a value, or the number in front of the parentheses. In this case, we see a 3, but more importantly, we see a positive 3. Since it's positive, it means our parabola will be facing upwards. If it's facing upwards, then it means you can clearly see there is one particular point that happens at the low side of the graph. Since it's the lowest point, that means this will have a minimum. The last part is to identify the max or min value. Well, the max or min means how high or how low. Again, think of which axis goes up and down. Well, that would be your y-axis, which means look at your y value from the vertex, and you will have your min value, which is a negative 6. For b, we have the function f of x equals -1/2, parentheses, x plus 2, close parentheses, squared plus 5. And again, we're being asked to identify the vertex, axis of symmetry, max or min, and the max or min value. This is your try-it problem. Let's see how you did. Well, first we have to identify the vertex, which is an ordered pair. Now, it needs to be of the form hk. But notice the h value. H has to be of the form, as part of it, x minus some value. Ours is not of the form of x minus. Ours says x plus 2. So what number could we plug in to make it turn into x plus 2? Well, that would be -2. So in this case, our h value would be -2. Next, we need to find our k value. K happens outside the function, which we see is +5. So our k value will be 5. Next is our axis of symmetry. Axis of symmetry is always of the form x equals, and it's the h value from our vertex. Since we do know our h value, we know our axis of symmetry. It too will be x equals -2. To determine whether it's max or min, we look at the a value or the leading value. And in this case, we notice our -1/2 is a negative. Since it's negative, it means there is a reflection across the x-axis, which means it's a downward-facing parabola. Since it's downward-facing, we see a high point, which means we have a maximum or a max in this case. The last part is to identify the max or min value, which again means how high or how low the graph goes, which pertains to the y-axis. Since we know our y value from the vertex, we know our max min value. It is 5. What if the quadratic function is not written like f of x equals a parentheses x minus h close parentheses squared plus k, where you can see the vertex values of h and k? What if it is written in the form of f of x equals ax squared plus bx plus c? How would you find the vertex? Those are good questions. Here's how you would do it. To find the vertex of the form f of x equals ax squared plus bx plus c. In this case, you have to go and find it. To find the h value, you find -b over 2a, where b is the coefficient of the middle term and a is the leading coefficient. Once you have the result for h, you then plug the result into the function to find the corresponding k value. So again, your vertex is made up of your h, which is -b over 2a, and then k is the result of plugging that value into the function. Let's look at an example. Example 2. Identify the vertex. For a, we have f of x equals x squared minus 8x plus 12. Now notice the direction. It said identify the vertex. The vertex is the ordered pair of the form hk. Now look at the function. Is it written in a form where you can easily identify h and k? No. Instead, this is written in standard form, which means we have to go and find the h value. Now we just learned h equals -b over 2a. Well, our b value is -8. Our a value is 1. Now that we've plugged the values into the equation, now we need to simplify. In the top, we have the opposite of -8, which we know is +8. In the bottom, 2 times 1, well, that's 2. So we look at the fraction and we know 8 divided by 2, well, that's the same thing as 4. now that we've identified our h value, that means we have part of our vertex. And so now that we have the h value, we're ready to find our k value. To do that, we plug in a 4 into the function. So now we need to work out f of 4 equals 4 squared minus 8 times 4 plus 12. To simplify, we need to follow GEMS or order of operations. We cannot do anything inside the grouping symbols, but we do have exponents. 4 squared, well, that gives us 16. Next, we look for any multiplication or division. Well, in the middle, we have a negative 8 times 4, which gives us negative 32. Now we're ready for subtraction and addition in order from left to right. 16 minus 32 is negative 16. And then the last step, negative 16 plus 12, gives us negative 4. And since we found the result of plugging in a 4, that means we just found our k value. So for example A, our vertex is 4, negative 4. Let's try another one. For B, we have g of x equals negative 2x squared plus 2x plus 9. Now again, we're being asked to find the vertex, which means we're looking for the ordered pair, specifically h, k. So we look how the function's written. Can we easily identify h and k? No. This is written in standard form, so we have to go and look for it. H can be found as negative b over 2a. Well, from the function, our b value is 2. Our a value is negative 2. Now we need to simplify. In the top, we have the opposite of 2, which we know is negative 2. And in the bottom, 2 times negative 2, well, that's negative 4. Since we have a fraction, we need to try to reduce, but let's deal with the signs first. A negative divided by a negative, well, that's a positive. And 2 over 4 can reduce, and we find h equals 1/2. So since we have our h value, that means we're ready now to find our k value. To do that, we must plug in 1/2 into the function. So we have f of 1/2 equals negative 2 times 1/2 squared plus 2 times 1/2 plus 9. According to GEMS or order of operations, we must do the exponent first. 1/2 squared simply means 1/2 times 1/2, which gives us 1/4. From here, we do multiplication division. Negative 2 times 1/4, well, negative 2 is the same thing as negative 2 over 1. We multiply top times top, bottom times bottom, and then if possible, we reduce. So for our first term, that reduces to a negative 1/2. In the middle, we have 2 times 1/2, which gives us a result of 1, and then we still have that plus 9. So we've performed all the multiplication division, now we're ready for addition and subtraction. Now I notice we're supposed to go addition subtraction in order from left to right, but notice on the right hand side we have 2 whole numbers. We are being asked to add 1 plus 9. Since they're already whole numbers, we can add that to go ahead and give us 10. So now our function is f of 1/2 equals negative 1/2 plus 10. But from here, we're going to have to do a little bit of work. Since 10 is not a fraction, we need to make it into 1. And we simply do that by writing it 10 over 1. But because we're being asked to add 2 fractions, they must have a common denominator, which in this case would be a denominator of 2. So rewriting the problem, it now becomes f of 1/2 equals negative 1/2 plus 20 over 2. And now that they're speaking the same language with a common denominator, we can now add these 2 fractions. And the result is 19 over 2. Since it cannot be reduced, this is your k value. Our vertex is 1/2, 19 over 2. For C, we have h of x equals 2, parentheses, x plus 3, close parentheses, squared plus 7. Now again, because we're being asked to find the vertex, we are looking for an ordered pair of the form h comma k. Now we look at how the function is written. Can I easily identify my vertex, my h and k? Yes. Notice this is written in that form, so we need to find our h and k value. Now notice, the form has to be written in the form of x minus some value. Well, what would be our value? X minus what would create x plus 3? Well, that must be negative 3. So in this case, our h value is negative 3. To find the k value, it must be plus some value. What number would that be? Well, that would be 7. So our k value is 7. So in other words, our vertex is negative 3, 7.